Hey everybody, I just thought I'd do a quick video with some basic signal processing type stuff. This is really low level, so if you have some experience with signal processing, data science, etc., this is going to be kind of entry level. I'm using some pre-processed EKG data, 2 channels of it, pulling it in from a mat.mat file, so it's already converted. Normally, when you get EKG data, you'd have to, if you're doing it live, you'd have to stream it into Matlab. I'm using Matlab here. If you're using Matlab, you'd have to stream it in. If you're using pre-recorded data, usually you have to convert it from like a comma-separated value CSV file or any number of other file types. I think this one is actually converted from like what do you call it? Like a proprietary EKG format that's used like in a hospital type setting. Basically, what I wanted to do is show you how to load up data from a .mat file if you already have it in .mat format. And basically, once you pull that data in, go through and get basically like a frequency type thing, so you can get it to come out with the correct values. And then finally, the last part of this will be trying to get the whole purpose of this would be to do something fun with it, which in this case we're going to try to get a heart rate value. So the first step is to first I usually do this. I do a couple different things. So this is your editor window. This is your workspace. This is your command window. And there's a little thing that pops out on the side that shows you all the files that you have. In this case, I already saved it as untitled.m because I don't know. Normally I'd give it a really good name, but in this case I'm not going to. So normally what I do is I start off by putting like a title at the top. So this script, something like this script tests the feasibility of, hopefully I'm spelling all of this right, of importing, my R key is messed up, importing, oh, it's working today, yay, raw ECG, or EKG, let's go with both, EKG, it depends on which one you're used to saying, tracing data into Matlab. So I always write, okay, so Matlab is supposed to be capitalized when you look at the name on the corner. It says Matlab, but it looks like it's shouting, so I always like change it to like, in my own code, I'm like Matlab, just to be safe. I'm like, oh no, and in this case I'll do it full caps. Matlab, okay, anyways, Matlab for processing. Oh, see, there's the for processing, the delay on that R key. Okay, so first thing I always do when I pull in data and go to work with it, I always clear up my thing, clear up all the stuff. So I go in CLF to clear the frame, or clear stuff. Here, let's put a clear stuff. And you got CLF, clear the figure, clear frame. I just like to say frame, but it's figure, clear figure. And then you have clear, which clears the workspace, and then you have CLC, which clears everything. I think that's the order. I think that's correct. And then, so let's just clear everything out. So about any other data that you've been running through the system, any other stuff like that in your workspace, all the stuff that would be over here and down here, you get it cleared out, and all the commands that have been run. So CLC is clear command. So so now we've got it all cleared, and then what we're going to do is, and now this isn't running like live or anything. This isn't like using what's that, Jupyter Notebook or anything like that. Matlab, you run it and then it runs. It's like a compiler kind of. So then we want to load the EKG data. Load the EKG data. I'm switching between EKG and ECG for this video, but I guess I can put both. But they're the same thing. You have echocardiogram and echocardiogram. One's cardio with a K and one's cardio with a C. And I switch between them randomly because different textbooks use different things, different articles use different things. So I've gotten used to using both, so I switch between them interchangeably. Feel free to do this in your own data processing work. You can any articles you write or any classes you take, unless the teacher's like, oh, like I've had professors like, oh, you have to use ECG, not EKG, or you have to use EKG, not ECG. But for the most part, everybody just switches them, interchanges them randomly as they feel, because they mean the same thing. So let's do EKG equals load. We got to load the data. So here's where we load the data. In this case, it's 100 M. And I'm not sure where I got this. I might have gotten this from a class. So in that case, I apologize if I'm not citing it correctly. So that loads the data. And then EKG, let's have an EKG1 equals, normally I do a space like this, or do O1, depending on how many channels. We're doing 2 channels here, so we have EKG dot val 1 comma So that this is going to give you rows. Rows is 1. So this is the values. So you got row. So this is actually a sub file. This is actually like a struct in Python, but this is actually a big data frame. Here, let's pull it up real quick. Normally I do it this way. So what this is doing is it's pulling from row 1 everything in all the columns. So that's rows, columns. And so let's actually run this real quick, and we'll take a look at this real quick. I could do Control Enter, but I think I'm just going to run it from. I'm running it from up above. You can't see it right now, but it's making a figure because I did clear figure. So now we have EKG. It's a struct, so it's kind of like not a data frame, but the bigger thing in Python. So like it's a struct. You know, it's a structure. So you go into it, and it's a val, and it has two. We see it has 2 rows. Normally when you do the data, you wouldn't go straight into this step. What you do is you immediately go and run this to see what it looks like, because Matlab is really good with visualization of data. You can actually see all the data. You can just like scroll through it if you really want. So much data. Okay, anyways, so you can see how big it is. What we want to do is we want to pull that val data out to see how big it is. So we want to see how long this is without having to go this way. So what I'm doing is I'm going, okay, dot val. So val is a sub file within the struct. It's a component of the struct. And so structure is like a bunch of matrices stuck together. This is a 2-dimensional matrix, or a struct could be, I guess it's more like a 3D matrix. I don't know. But anyways, but it's different data. You can have different data in each one. So you have like val, and then you have like TS is timestamp, and then you have time spacing, and then you have frequency. Normally there'd be a frequency file in here. Since I don't see the frequency file, that's actually kind of frustrating because I'm like, how much time is passing? But I actually have a conversion for that. From when I processed this data before. So I think I have an idea of how big it is. So anyways, what we're going to do is we're going to pull that dot val. So this is like inside of EKG, we have dot val. So we have val. We want val from inside there. So that's what we're doing here. So we're going to go right here, and we're going to pull that in, and then we're going to run that. And that will give us the length. So it's 3,600 long with 3,600, what do you call it? Points, I guess, data points. So that's going to give us the first row 1, or yeah, row 1 with all the columns. So then now we want all the ones from the second one. So if you want to pull all the data out, normally I just pull one at a time. But sometimes if I'm going to be doing like data analysis, and I need a test set and a training set, I'll pull both, and I'll use one as a training set, usually the first one, and the second one as a test set to verify that my model works. So, oh wait, this is 2. This needs to be 2. So we're doing row 2. This is row 1. This is row 2. This colon means all the columns or all the values. So if the semicolon or the colon, semicolon, if the colon was here, that would mean all rows, and then you do whichever column you wanted. In this case, we're gonna normally I convert all of these. I don't like working with rows. I like working with columns. So normally I'd switch this over, and how you do that is you just go do something like this. You just hit that, and it would transpose it. But I'm not actually doing that right now because that's not that important. So now we just need to figure out what the time step on this is, and I actually have the time step data. So I'm just going to put that in real quick, and I'll explain the formula. Let's call it time step vector. Okay. TS, that's what we usually call our TF, time frame, whatever you want to call it. So I think this is a total of 10 seconds. So based on that, if this is 10 seconds, we go 0. So we're going to go 0 from 0 time to 10 divided by the length of the EKG. We're going to do EKG 1, just EKG 1, right? So from that, so we're going from 0 using a time step of this. This is the time step right here, the TS that we're referring to. So it's 10 divided by length. So we have 10 seconds divided by the length. The length is 3,600 units. It's 3,600 components. And so that's going to give us the time frame, which is like, what, 360? I don't know. 1/360th, something like that, of 1/360th of a second per step. So, and then we'll have and then we're going to take the maximum value, which is 10, minus the time step, right? Because we don't want it to, we have to have the exact same number of values. So what's going to happen, because if I went just to 10, say I went to 10 like this, what's going to happen is they're going to have one extra value because we didn't subtract out at the end, because this is the time step. So we're starting at 0. If we started at this value and then stepped by that each time, then we would have the right number of values. And when we'd be done, we'd have 3,600 values. In this case, if we do it this way, we have 3,601 values. So we need to subtract that one, just subtract 1, 10 over, basically one time step out, so we have the same number of values. I could actually show you that in just a sec here. So that's gonna, so when I do this, it'll be 3,600 steps. Did I put enough? No, I need one more parenthesis there. And then we'll suppress the output. So when you put the semicolon in MATLAB, it suppresses the output. Otherwise, it'll print everything to this window down here. So I just like to, okay, so let's run this and see what happens. Hopefully I did it right. Yeah, see, so we have 3600 here for time step. If I take this out, what happens and just make it 10, like this, the max is 10 seconds, right? So if I do that, what I end up happening is 3601, see? So you have to have that, Control Z that. So that's what you want to do. And if, watch this, if I leave this open, this is what happens. So you end up all the values, all the data. It's just like printing all of it, all the time steps. So I'm actually going to suppress that output. And then I'm going to save real quick because I don't like to risk losing my data, what I'm working on. So this is working right. I'll run it again. Here we go. So we got 3600 steps. So now we can plot. When you plot, you need an X and a Y. In this case, the X is the timestamp and the Y is the EKG values. These are the amplitudes of the EKG. The beat amplitudes, like how strongly it's beating, basically, the quantification of that. So we're going to just go plot. I mean, it's really easy. Here, let's comment our code. Don't forget to comment your code. Plot data. There we go. That sounds like a good. Look at my comment. It's so insightful. TS, comma EKG1. And just because I like to do this, hold on. I put a semicolon after it. I don't think you have to, but run it. And now I have this plot. This is what it plotted out. So we've got, looks like we've got 13 peaks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you get 13 peaks in 10 seconds. So that's whatever that heart rate is. So what you can do with this is, now that we have this, we don't need these anymore because we know that that's a struct. We know it's a struct. Okay, and so you got the hold on, and so we're going to go down here and we're going to go, okay, so now we probably should title this, actually. I'm going to title this real quick. So just so you have an idea, in case you're plotting some other data and you're watching this video, you can go, oh, look, I got I didn't leave you out too much data, so you can't just do it. So that's going to title it, and then we also need what's X label, and this is actually the same in, what was it, Seaborn or one of the Python languages. I think it uses the same one, X label, Y label. It's not Seaborn. Which one is it? Matplotlib, I think. Anyway, so it uses the same kind of X label, Y label type of thing. Might have the wrong. Might be a SciPy or one of those ones, or pandas. In a second, this is the same format, basically. What's nice about Python, actually, like on a side note, is that I was surprised it was so similar. I've been using Matlab for like 5 years. It was so easy to go into Python. I wasn't sure if I was actually learning anything. So then I came back and I was like, I could just program, and I was like, why is this? It's so easy. Like, I don't understand. I did Java for a while too, and I was like, and I used to do C++ back in high school and when I first started college. So years and years ago, like 10, 12 years ago, I don't know. So I would do this. I would program these other languages, and it's like Python and Matlab were so like, they just like flowed together that I didn't really realize I was learning Python, because they were so like, I felt they were very similar. Anyways, so here you go. There's your things. Let's run this again so you can see the run it. Where's my plot? There it is. Yeah. See, now we got our thing. So before it didn't have these, so now it has these. So that's cool. And then I should probably close that. No, we'll leave it. We'll leave it. Okay. And then I'm going to go down here. So now what we want to do is we want to try to get the actual information from, or get a count of how many heartbeats have happened. So one way to do this is to just give a threshold. Let's look at this data here. We've got 13 peaks, so we need to find 13 peaks. So there's lots of little peaks inside here. So if we just run the normal thing, so normally you'd use find peaks. Find peaks. See, it's very MATLAB's very friendly that way. So we have PKF. This is actually from the documentation. I'm just writing in the formula the function for it. Find peaks, and then we just put in, you can like displacement. That's it. Like that's it. Like displacement is going to be your y value, your up and down. So it's going to be that's going to be this signal here. This signal value here is going to be the displacement. So that's what the formula is. We'll just comment this out real quick. We're going to use something, we're going to basically copy that and just reuse it. There's actually more. There's a whole bunch more factors you can use, and I'll show that in a minute. But what I want to do first was show you just like the function. So if we just run this, we got to set what displacement is. Let's say displacement is what is that? EKG1, G1, like that. So I guess I could assign it to displacement. But anyways, I'm not going to do that. I'm just going to put it in the function directly. And then we just run it. And what you're going to see over here is we've got 649 peaks. Well, that's not right. We want the number of peaks on the QRS complex, the max peak on the QRS complex, which is right here. It's this big spike. It's the biggest electrical signal for the heart. And so what we want is we want to be able to count these. Well, the thing is, we're not getting close. So what looks like a good threshold? We were going to threshold this. Let's set this to thresholds. So we're going to say, oh, this is the threshold. So let's say 1150 is the threshold. I mean, it could go lower, it could go higher because, you know, it's nonlinear, non-stationary data, right? So it's going to drift. I mean, it's going to be all over the place. But the thing is, we know that the peak is, if the person's heart's beating like this, the peak is going to be good. Unless they're having something wrong or the detection is getting messed up, it's not going to be going down into this range, like down here where you see multiple peaks. So if we set it at like 975, we'd get a lot of peaks, but we get a fewer than 649. Right now we're getting every single peak. Every time it makes a little triangle shape, right? So what we're going to want to do is we're going to want to tighten that down. So what we do is we look through the documentation, and actually what I want to do is I want to go like this, help. And we're going to do, you can't see all of that at the bottom there. Let's see if I can stretch this up a little bit. No, it's not working. Okay, help. And then we're going to do, so anytime you need to learn something in Matlab, you just put help and then whatever the thing is. So in this case, we're going to do find peaks. And I'm not sure if this is part of like Matlab normally. I would assume it is because it's just a peak finding. So it's going to tell us all the information. So here, I'll show you. This is all the information. So help find peaks. So we're using find peaks as the command. I found it on the internet. I just went on the internet and was like, oh, find peaks. I need to find peaks. And so you go through and you just look at it and you go, okay, here's all the stuff. And I went through here and I found one that was pretty cool. It's threshold. And that I was like, oh, that's pretty cool. So it only finds peaks that are greater than both adjacent samples by the threshold TH. Okay, so you can do a threshold that way. What I ended up doing was minimum peak height. So it's right here, minimum peak height. So that's what I ended up doing when I did this as a project, when I was trying to create like a real-time heart rate monitor to go with a bunch of other factors and like, you know, non-stationarity index and stuff like that for the EKG data. So this is kind of what I did. So in this case, you can just go like this. You go EKG, that's the data, and we're gonna just type in min peak height. It's just a control word, kind of like in any other programming language where you have set function. And so there you go, that should do it. And you just run it and okay, so we set it at 1100. We said what we're saying, we're going to set it at, I put it at 1100 just out of reflex. 1100. So that's a nice low peak. We could do 1150 if you really wanted. I'm just going to go with, let's go with 1100. We go with 1050, it looks like, even, because it's only looking at the top and like where it's looking for anytime there's a triangle. So in this case, so up, down, and there's an angle, right? And so basically if the point on the left is lower than the point on the right, and the point on the right is lower than the point on the left, then you know that this is going to be, in their sequential, you're going to know that this is going to be a peak. So it's not the best way to do it, especially if someone has like heart problems. This is not going to be the best way to do it because this peak could be down here. And it depends really on which channel you're using, because there's going to be a whole bunch of channels, like if you're using like 12 lead. And some of those are going to be all messed up. But you can use the same technique for picking up like all sorts of like ST elevation, all the different disorders you can have. So this is one way to do it. So we're going to run it. We should get 13, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there should be 13 peaks. So now we're going to just run this and see if we have 13 QRS complex, basically. That's what we're counting. Because I mean the ventricle depolarization is like basically that's going to give you the best results for most people's hearts in most channels, especially like if you're using like channel 1 out of, say you have a full 12 lead. I mean, I think channel 1 would be a good one to use. I can't remember. Anyways, I can't remember all the numbers. It's been a while since I worked with EKG data. So yeah. Anyways, PK app. So this is going to be what we're going to do. We're going to run it and we'll see what we get. Oh, 13. There you go. 13. And now we can see what we can see where the times are for these. And you can get, this is time. So if we wanted to get the exact time, we take PK time and we divide it by 3600, and you can get the seconds where it's at. Let's do that real quick. So we have PK time divided by, what was it? Let's just do length, because length is 3600, right? I usually use length because it's you can change the file that you're using. If you set it to 3600 and hard code it, oops, If you hard code it to 3600 and you put a different EKG data, or you have live data coming in that's like streaming in, it'll mess it up. So you really want to have that it'll change basically. You could have a data set with like 100 seconds, or 20 minutes worth of data, or whatever it would be, or if you do overnight, like you have an overnight heart monitor where the patient takes it home with them, that would be like 24 hours of data approximately, or 23 hours of data. And so you really don't want to set it to that. You want to set it to the length of whatever it is. Obviously, you wouldn't be programming the controller for a take-home heart monitor. You probably wouldn't be programming that with Matlab, although you probably could. You'd probably be using something where it's like an exe or executable file, or something that's proprietary to the software. So it'd be like probably like Python or something, or C, probably C++ maybe. I don't know. But anyways, you have PK time, and we want to set this to a variable, so that because if we don't set it to a variable, it'll just print it out here, and I want it to come up over here so we can have it as a variable, like a set workspace variable. So we're going to say actual time. I don't know. Actual time. Actual time equals. There we go. Let's run this and see what it gives us. And so we got actual time. And that's telling us how many seconds in, and that's going to go all the way through. And there you go. So the last time is at 0.9892 seconds, and then you have all your peaks. And then if you really need like a range of peaks, you can find out how far apart the points are before and after this exact spot using the original PK time value. So there you go. That's about how I did it. Oh, see, I didn't suppress the data, so it's sticking out there. Let's just do that and run it again. Oh no, I didn't suppress this one either. Let's just suppress everything. Why not? Woo! Okay, cool. So now we have all of our information, and there you go. That's how you do it. You got your plot, and then you can count the number of peaks. And this can be used with any. You could use this with any sinusoid. You could use this with any exponential function that is like a Fourier series, or whatever they're called. Series notation. Anything that's series notation. Anyways, I hope this was informative, and thanks for watching.